Hello, dear students. This is Ms. Shimaa Ghandour. I'll be your physics teacher. Okay, here we have this topic about motion. The terms we're going to deal with are speed, velocity, and acceleration, and also motion graphs. Let's know first what is kinematics. Kinematics is the study of motion without concerning the cause of motion. So the kinematics is the part of physics or a branch of physics that study the motion of the objects without the reasons behind this motion. Okay, so the object may be in motion or at rest. What does it mean if we said that the body in motion? It means that the body changes position as time passes. So here, when we say that the body in motion, it means that the body is not existing in one position, but the body, it changes its position as time passes. So what's meant by a body at rest? It will be when the body doesn't change position as time passes. The terms we use to describe the motion of the object, like distance, displacement, speed, velocity, time, and acceleration. So here are the terms that we're going to deal with when we're describing the motion of the object. So here we have part one. It's about motion and speed. So what is speed? Speed is the distance an object travels per unit of time. So if I said that the body is moving with speed 2 meters per second, what does it mean? It means that that body covers 2 meters in each second, covers 2 meters in each unit of time, because the unit of time is second. We know that time is measured in seconds, and distance or displacement is measured in meters. Okay, so how to calculate the speed of the object? Speed equals distance over time, the total distance covered over the time taken by the body to cover this distance. Here we have the units. Distance is in meters, time is in seconds, so the unit of speed is meter per second. Here we have an example. A snail takes 5 seconds to crawl across the ruler. So here we can find that the snail starts from 0. Here is the first position, and it ends its motion at 10. Okay, and it covered this distance in 5 seconds. So to find the speed, we're going to write speed equals distance over time. The distance here is 10 and the time is 5. So it will be, here we have the answer is 2 meters per second. Here we have another example. A car drives 250 meters in 1 minute. In this case, we have to convert minutes to seconds because we know that the SI unit of time is second. So here to convert it from 1 minute equals how many seconds? You're going to multiply by 60. So here's the time in seconds is 60 seconds. So when you divide, speed equals distance over time. The distance here is 250 over 60. And in this case, the answer will be 4.17 meter per second. Some students like to use the triangle formula to here, distance, speed, time. If you want to calculate speed, it will be distance over time. If you're asked to find the time, so you're going to divide distance over speed. And if you're asked to find the distance covered, you're going to multiply speed times time. We've mentioned that we have distance and displacement. Actually, distance and displacement both are length. Both are length. But what is the difference between them? The difference between them that distance is a scalar quantity, but displacement is a vector quantity. So distance, how far an object moves in total, the actual the actual length covered by the object. But displacement, the distance and the direction an object moved from a starting position. Again, here we have, if we have an object started its motion from point A to point B, then to point C, then to D. Suppose that the distance covered here is 7 meters, and the distance here is 4. The distance here, say it's 10 meters. So to find the actual distance or the actual length covered by the object, you're going to add each step or each length covered by the object. So here, distance will be 7 plus 4 plus 10. So it will be 21 meters. We didn't mention any direction because distance is a scalar quantity defined by magnitude only. We covered these points before, scalar and vector. Displacement, the distance and direction. So it's the magnitude and the direction. That's why displacement is a vector quantity defined by magnitude and direction. So back to the first, back to this drawing. If your drawing has this line and suppose that it's 20 or 20 meters. So here, in this case, the displacement equals will be 20 meters, and we have to mention the direction. So we're going 20 meters right, to the right direction. Okay, here we have drawings that clarify uh, the difference between distance and displacement. Here, the beginning of the track, and here is the end of the track. The actual length of this track all over the city, it's 176 meters. So if one of this debris starts its motion from this part, from this position, and covered all the distance or the length inside these streets and around everything here, it will end its motion with 176 meters. It covered 176 meters. But about the displacement of belly, it's only 1 meter. Why 1 meter? It's only the length between the starting point to directly to the ending point. From the starting point, from the point the body started its motion with, to the ending point directly. But distance, the actual length, all the length covered by the object. Here we have another example. Here, if the body started its motion, suppose here we have A, B, C, D. From point A to point C, the length is 90 meters. So here in this case, because the direction is directed from point A to point C, so in this case, we have the distance equals the displacement. Both are 90 meters. What if the object moved from A to B, then to C? What will happen? Here we will find that the distance will be 90 meters plus 90 meters. Here the distance equals 90 meters, اللي هي from A to B, plus 90 meters, which is from B to C. Which is 90 meters as well. So the total will be 180. But here the displacement from A to C, suppose that it's given on the drawing, so it will be, the displacement will be 127 meters. And we have to write the direction, so it will be up or to the north, up or north. So you have to mention the direction. Then the object continue its motion to point D. What will be the distance? It will be 90 plus 90 plus 90. So the total distance will be 270 meters. But in case of displacement, because we said that displacement is the direct length between the starting point to the ending point. In this case, from A to D, the starting point is point A, and the ending point or the body ends its motion at point D. So the direct length from A to D, it will be 90 meters. I hope the difference is clear now between distance and displacement. The same here. What if the body moved from A to B to C to D? Here, displacement is zero. Okay, What if the object returns back to the starting point? Here, the starting point here, A, B, C, D. If the object returns back to the starting point, to find the distance, we know now that the distance is the actual length covered by the object. So it will be 90 plus 90 plus 90 plus 90. So it will be 360. But displacement here is 0. Why? Because the starting point here is the ending point. It's the same point. The body returns back. We say that the body returns back to the starting point. Okay, in this part, we're going to discuss distance time graphs. Distance time graphs, the slope of distance time graphs represents speed. The motion of an object can be graphed. Distance time graph shows the motion of a certain object in line graph form. On the x-axis, we plot the time. And on the y-axis, we plot distance. So here, distance time graph, here the time, and we have to write the unit used. Here, the distance in meters. So the slope or the gradient of this graph represents speed. So here we're graphing the speed of the object. Okay. Here the time intervals are 0, 1, 2, 3. So here we're graphing the motion of the object in each second. And here distance in meter, in each second, here we will find that the body, in each second, the body covers 2 meters. So here to draw the graph, in the first second, the body covered 2 meters. In the second second, the body covered 4 meters. Until the body reached 3 seconds, the body was covering 6 meters, and so on. In this case, we will find that in each time interval from 0 to 1, the body covered equal distances. Equal distance in equal interval of time. From 0 to 1, the difference is 1. Here, the difference is 2. Here, the difference is still 1. The difference is 2. From 2 to 3, the difference is 1. So here we have equal intervals of time. From 4 to 6, the body is still covering 2. And here is still the body covering 2 meters per second. But here we will find that the body stopped at 8 meters from the starting point, which means that the body here in this part is at rest. You remember that we defined the body at rest means the body doesn't change its position as time passes. Here the body is still existing at 8 meters from the starting point, but we can observe that the time is still passing because time never stops. Okay, so here in this part, we can say that the body is at rest because the body is not changing its position as time passes. Okay, so what about the first part? How can we describe the motion of the first part of the graph? Here we can say that the body covers equal distances in equal intervals of time, which means that the body is moving with constant speed. Constant speed or steady speed. constant speed or steady speed. So what does it mean? The body is moving with constant speed or steady speed. It means that the body covers equal distances in equal intervals of time. Okay, so here in this graph, the body from time 0 to time 4, the body was moving with constant speed. From time 4 seconds to time 8 seconds, the body was at rest, or we can say stationary. Okay, and here from time 8 seconds to time 10 seconds, we can find that the graph is a straight line. It means that the body is moving with constant speed or steady speed. Okay, so here from 8 to 12, from, from second 8 to second 9, is still 1 second, the same interval. But here the body covered 4 meters. And here from 12 to 16, the body covered 4 meters. Here it means that the body moves with constant speed. But if we compare this part or this section of the graph with the first part, we will find that from 8 to 10, the body was moving faster. How? Because the body covers 4 meters in 1 second. But in the first part, the body was covering only 2 meters in 1 second. So here the body is still moving with constant speed, but faster. Faster than section 1, or the first section of the graph. Okay? How can you tell from the shape of the graph without even doing any calculations to compare two speeds? Here the graph, this part of the graph, we say it's steeper. What does steeper mean? Steeper, the steeper graph means that the graph moving towards the y-axis rather than x-axis. So if you compare the first section of the graph, this part of the graph, and this part, you will find that the last section of the graph is faster than the first section. Here, how to find speed from distance time graph. We said before that slope of distance time graph equals speed. So here for the first section, to find the speed, you will do some calculation. Speed equals distance over time. The distance here was 8 meters and the time is 4 seconds. So you're going to divide 8 over 4. So here the body moves with constant speed of 2 meters per second, which means that the body covers 2 meters in each second. Here, we don't have distance covered. The body still existing at the same point. So here, the body is at rest, which means that the speed equals 0. Here in this section, we will find that distance covered from 8 to 10 was 8 meters divided 2, so it covers 4 meters in each second. Here we have different distance time graphs. The first graph shows that the object is moving with constant speed or steady speed, as we said before, and the body is moving away from the starting point. Here, the body covers equal distances in equal intervals of time. Here, the body still moves with constant speed, but the body here is returning back to the original point. Suppose you moved from your home to the school with constant speed, and this graph representing your motion from home to school. Here represents your motion from school to home. So here on distance time graph, if the graph is moving downward, it means that the body is returning back to the original point. And this represents the body at rest or stationary. So no speed. The speed here is zero. The body is standing still. The body is not moving. Here on distance time graph, analysis of distance time graph, the distance in meter stays the same. The distance is not increasing or moving to the backward, okay? As the time is increases, the time, and as we said before, the time never stops. Therefore, the object is at rest or not moving, or we can say stationary. Here, the object is moving away from the reference point or the starting point. The object is moving at a constant speed, and we said before, constant speed means the body covers equal distances in equal intervals of time. The object is moving quickly. From where you know that the object is moving quickly? Because as we said before, the graph is steeper. The word steeper or the term steeper means that the graph is towards y-axis rather than x-axis. Here, the object is moving towards the reference point. The object is moving at a constant speed because the graph is a straight line. Whenever the graph is a straight line, means that the quantity represented by this graph is constant, have constant value. The object is moving slowly. Why? Because the graph is not steeper. Sometimes in the exam, you find this shape of the graph, and you're asked to interpret the graph or choose which uh, which section the body is moving with constant speed. So you're going to choose A and C. A and C, the body is moving with constant speed. Which part of the graph represents a body at rest? So it would be B, the body is at rest. In which section of the graph represents the motion of the body when it's returning back to the reference point? So it would be C, and so on. In part A, the object is moving away at a constant speed. In part B, the object is at rest. In part C, it's moving towards a constant speed. So here, what we covered today, we've talked about kinematics and the terms we use when describing motion. We exposed to distance, displacement, speed. We also explained what's meant by the body at rest. We've talked about speed and its formula. Here we had examples. Here's the difference between distance and displacement. And we had the example, detailed example. We also talked about distance time graphs, how to graph speed, how to interpret distance time graphs, how to find speed from distance time graph, how to describe the motion, and how to analyze a distance time graph. I hope everything was clear. Thank you. See you.